Good morning. Today we are going to do the exercise number 1.4, third problem. Just read the question. The following real numbers have decimal expansions as given below. So these are the decimal expansions they are given you. Then in each case, decide whether they are rational or not. And from each case, just look at this and find out whether they are rational or irrational. And then, if they are rational and of the form P by Q, what can you say about the prime factors of Q? If they are rational, what you can do? Of the form P by Q, that you know, P and Q are the integers. And then what can you say about the prime factors of Q? What about the denominator of this rational number? So before doing this one, what you have to remember? You have to remember about rational and irrational number. So rational and irrational number, what can you see? Rational, right? Rational means it should be in the form of P by Q. And P and Q are integers and Q should not be that, everything you know. And what about the decimal expansion? Do you remember the decimal expansion? The decimal expansion, rational numbers, decimal expansion, you have to remember. We have done already in the same exercise. So decimal expansion of rational number. What are the Q? What are the decimal expansion? Whether it will be terminate or non-terminate, just remember. First thing you have to remember, rational numbers, the decimal expansion will be terminating or what do you think? Non-terminating repeating. So it is non-terminating repeating. So this is the decimal expansion condition for the rational numbers. What would be rational numbers? The thing you have to remember, it is double n is there. So irrational numbers. Decimal expansion. The rational numbers decimal expansion will be non-terminating. Double n means non-terminating, non-recurring or non-repeating. N and here also n, double n is non-recurring. Okay, or non-repeating it will be. So these are things you have to remember, then only we will do. I will give some examples for this, then you will remember how to do this one. Okay. Now look, I wrote like this. Rational numbers should be in the form of P by Q and the decimal expansion will be terminating or non-terminating repeating. And while rational numbers, the decimal expansion will be non-terminating, non-repeating. And it is not in the form of P by Q, root 2, root 3, etc. It goes on. So this one will be 2 by 5. That fractional form we can say. So now we will start the decimal expansions form. Now terminating. Terminating means what? It stops. Not repeating or just we cannot say any etc. or just it will stops. So example I will give you. Now already I studied 17 by 8. This 17 by 8, just look to the Q. This is P by Q. Q is 8. It is a factor, we can write it as 17 by 8 is 2 cube. Right? That means the factor is only 2 is there. Only 2 is there. And you got the answer as 2.135. Now look. This decimal expansion terminates, stops. So 2.135. When this Q is Q is in the form of 2 only. Clear? The factor is only 2 is there. And it is terminates. Then next one. Next example is 100 divided by 25. Just look up the factors of Q. It is 100 divided by 25 means 5 square. What are 100 divided by 25? You will get the answer 4. This also terminates. And the factor is only 5 is there. 2 is there, then you got terminate decimal expansion. 5 is there, then you got the terminating expansion. Then next one more thing I will give you. 325 divided by 100. What about this one? You know the answer also. What do you think about the factors of Q? It is 325 by, it is 100 means it is 25 into 4. Means this can be written as 325 by 5 square into 2 square. Right? And this also the answer is 0.325. That you know. Sorry, it is not 0.325, it is 3.25. Right? So now look, here the factors are 5 and 2 is there. Again we got terminating. So what can we find out from these examples? The decimal expansion, the rational numbers decimal expansion terminates when the factors of Q either 2 or 5, or again we can say 2 into 5. That you have studied already, 2 raised to m into 5 raised to n. Then it terminates. Clear? Either the factor Q should be, only 2 should be there. 2 raised to something. Or 5 raised to something. Or 2 raised to m into 5 raised to n. Then only the decimal expansion will terminate. What would the rational numbers non-terminating repeating means? I will give you another example now. It is from the textbook. 64 by 455. And this can be written as 64 by 5 into 7 into 13. Okay, and you will get the answer as 0.14065,934, and it is bar. Means again it is repeating 14065,934, right? That means it is non-terminating repeating. And what happens? Here look, only 5 is there and some other factors we got. Okay, I will give one more example then. Next example. The example is 77 by 210. Okay. 77 by 210. Again we are taking the factors of Q. 77 means later we will find it. 77 divided by 210 can be written as 2 into 3 into 5 into 7. Again 77 is there and 77 can be written as 7 into 11, and here 7 is there, so we can cancel 7 and 7. It will be 11 by, this will be your answer, 2 into 3 into 5. And the answer we will get it as 0.36 bar. Means 0.36666, etc. Again also just remember, here it is non-terminating repeating. Right? And what are things you have to remember? The things you have to remember is, here non-terminating repeating, just look to the factors of Q. Whether it is in the form of 2 raised to m into 5 raised to n, or 2 alone, or 5 alone. No. Just look here, it is with the 5 another some factors are there. Extra factors are there. Then we can say it is non-terminating repeating. Take the next example. What you understood from here? Here 7 and we split into 77 and then 210 we split and 7 and 7 cancel and we got it like this 11 by 2 into 3 into 5. What can you say about these factors? They have 2 raised to m into 5 raised to n, but again one more factor also there. So we got 0.3, 6, 6, 6, 6, etc. Non-terminating repeating. So what can you understand from these examples? I hope already you have studied. Again I am just telling you, have to remember this one. What you have to understand from there? So when it is terminating means the factor of q should be 2, 5 or 2 into 5. That means 2 raised to m into 5 raised to n. Then it will be terminating. Clear? Hope you understood. When it is terminating means what you have to do? You have to just find out whether it is 2, the factor of q will be either 2 or 5 or 2 raised to m into 5 raised to n it will be. Then it will be terminated. What are non-terminating repeating? Non-terminating repeating means either it will be 5 will be there but extra some other factors also will be there. Or 2 will be there and some other extra factors will be there. Or 2 into 5 into some other factors will be there. Then we will get the answer as non-terminating repeating. Hope you understood. Okay. Now next one. Irrational decimal expansion. Irrational decimal expansion means it will be non-terminating, non-repeating. I told you already, you have to remember about the double N. That means non-terminating, non-repeating. And I will give the examples also. Non-terminating, non-repeating means, you suppose you will get like this 0.312. It is non-terminating, so it will go on. Non-repeating also, if suppose it is 2, 1, again 2, 2, 1, 1, then again 2, 2, 2, 1, 1, etc. goes on. That means it is etc. comes means it is non-terminating and it is non-repeating also. If again it is 3, 1, 2, 2, again 3, 1, 2, 2, again repeat it will be repeats. It is non-repeating also. So this is called decimal expansion, non-terminating, non-terminating, non-repeating. Hope it is clear. Now we will do the problem. We will do the first question. 1. 43.123456789. Answers. Right. Okay, just look to decimal expansion. How will you find out whether it is rational? First they ask you to find out which are the rational. And then from the rational numbers you have to find out what is the form of q. So is it rational or irrational? Just find out. How will you find out? Rational numbers decimal expansion is? Yes? Tell me. It will be terminating or non-terminating repeating. So is it terminating? Yes, it terminates. It means it stops. Till now it stops. There is no etc. So what we can say then? This is rational. Right? Now what is the next thing then? You have to find out the form of q. So we'll write in sentences. Here the decimal expansion is the decimal expansion is, for reason also you can write, is terminating decimal. Therefore, what we can say? Therefore, the number is rational. Now, the next step. What you can say about the next step? What about the Q? P by Q form it is. Rational means it will be P by Q form. You have to tell about Q. What about the form of Q? Can you remember anything? It should be either 2 or 5 or 2 raised to m into 5 raised to n. So that also we can write. Prime factors of its denominator are of the form two raised to m into 5 raised to n, where m and n are non-negative integers. So you have to remember about this factors, so 2 raised to m into 5 raised to n. So we'll pass to the next question then, second question. What is the second question? Second question is 0.1201, 2001, 20001, 20001, etc. It goes on. What can you see? Is it terminating? No, it is not terminating. What are non-terminating? Repeating. It is non-terminating, but it is not repeating. So it will know. What we can say then? Is it rational or irrational? It is irrational. Right? That means no need to find out the form of Q. Now we'll do the third problem then. This is the third question. 43.123456789 bar. That means bar comes means same number, same digits are repeating. Means what? It will repeat and it goes on. It will not terminate. That means this is non-terminating, and then what you can say then? Non-terminating and it is repeating. Non-terminating, repeating means what? Is it a rational or irrational? It is rational. So it is a non-repeating, non-terminating, repeating decimal expansion. Therefore, it is rational. So when it is rational means what you have to do? You have to find out the value of Q. How will you find out? It is repeating means what you observed from the earlier class. If it is 2 raised to m into either 2 is there or 5 is there, or 2 raised to m into 5 raised to n is there, means it will terminate. If extra factors are there, means what you can say? It is not terminating, repeating. Just find out the examples I just already written. Okay, just find out. So it will be, it is, what we can say then? It is rational, and Q will have, other factors, with 2 and 5. This is the thing you have to write. When maybe 2 into 5 into 7, or 2 into 5 into 13 into 7, or just any other number. Okay, prime numbers will be there. So when it is non-terminating, repeating means you have to remember that with the 2 and 5 some other factors will be there. So these are the problems we have to do it in exercise number 1.4, third question. Now we will start the polynomials geometrical representation. Geometrical representation of a quadratic polynomial. Already you know the form of a quadratic polynomial. It is ax square plus bx plus c. and the degree is 2, so it is a quadratic polynomial. And how many zeros there will be? Already told you. According to the degree, it will be the number of zeros there will be. So 2 is here, so it is a quadratic polynomial, and the number of zeros will be 2. And you already studied about the splitting the middle term. How will you find out the zeros of a quadratic polynomial? By splitting the middle term you can find out. So these all the things you are already studied. So we left this portion, that's why I am just going to take now. This one, ax square plus bx plus c is the form of a quadratic polynomial, and you know that the degree will be 2 and the number of zeros will be 2, right? And the zeros we can find out by, how will you find out zeros? Splitting the middle term we can find out. Now here we are going to find out by the geometrical representation. Suppose the question is y is equal to x square minus 3x minus 4. And you know in 9th standard you have studied how to draw the graph and all. You will find out some coordinates. With that coordinates you will get the graph. So later only just for the linear equation we will learn once again. So that will be explained later. Now you got the coordinates as negative 1 0, then 2 6, negative 2 6, and then 5 6, and then 2 negative 6, etc. If you look to the textbook, this page number 23 is given. When you draw the graph, so here this is the x dash, and then y dash. Here is 0, then 1, 2, 3, 4, 5, 6. Here negative 6 is there, so we have to make it correctly. So it will be negative 1, negative 2, negative 3, negative 4, negative 5, and here it is negative 6. Here it is x dash. Okay. Now next here on the top, it is 1, 2, 3, 4, 5, 6, 7, etc. Here also down also, negative 1, negative 2, negative 3, negative 4, negative 5. Here also negative 6. You have to maintain 1 centimeter distance, okay? Or 1 unit in the graph paper. Just I am just showing only, no need to draw it in your graph sheet and all. Just find out how we can do. First coordinates, negative 1, 0. Negative 1 in the x coordinate is negative 1 here, and 0 is y coordinate is 0. So it should not go to anywhere. Negative 1, 0. Here it is negative 1, 0. Next one, negative 2, 6. Negative 2. X coordinate is negative 2 and y coordinate is 6. This is y. So negative 2, 6 here it will be this negative 2, 6. Next one, 5, 6. Here it is 5 and here it is 6. So it is 5, 6. And the next one, 2, negative 6. 2 is here it is negative 6 is there. Here it is 2, negative 6. And one more point is 0, negative 4. 0, negative 4. 0 is here, negative 4 is here. So 0, negative 4. Already we have studied how to plot the coordinates in 9th standard. That's why I am not explaining anything. How to find out the coordinates. Everything I have studied in 9th standard. So again we will do it in the next lesson. All these things. This only roughly I want to show you, that's why. Okay, so here it is roughly I plotted the coordinates. Now we are going to draw the figure now. So start from here. It will become like this, and then from here it will go like this, and then coming like this. Actually it looks like this. U pattern you will find out. When you draw it in the graph sheet, it will be good. Like this is only roughly sketch. So now what you can do is, here two points. This is called parabola actually. That we will learn later. So this figure is called parabola and it intersects in 2 points in x-axis. X-axis means here. This is x-axis and this parabola intersect at 2 points in x-axis. X-axis, which are the 2 points? -1 and 4. So what you can do? By splitting the middle term, you can find out the same thing. With this solution, you can find out from here. By splitting the middle term, you will get the answer as -1 and 4. Just check it if you want means. From the geometrical figure, we can find out the zeros are, which are they? -1 and 4. From the geometrical figure. I think you understood. What you have to do is just draw the figure and find out which point it intersects on the x-axis. That you have to remember. Mainly x-axis you have to remember. Where it touches on the x-axis. How many times it touches? That will be the number of zeros. Clear? So this is the thing you have to remember, that how many times it touches? 2 times it touches the x-axis. There will be 2 zeros. Now which are the numbers it touches? Which are the coordinates it touches? Not coordinates, which point it touches? Here -1 and here it is 4. So that will be the zeros using the figure. And CBSE board told us that no need to make the children to draw the figures and all. Just from the figures, you have to find out how many zeros you can find out. Clear? Now we will say about it. Now we are going to learn about the number of zeros. How to find the number of zeros from the given figure. And the thing is that number of zeros of a polynomial is equal to the number of points of intersection. Intersection means cutting of the graph of the polynomial with the x-axis. Where it cuts on the x-axis, or how many times it cuts, or how many times it will intersect. That will be the number of zeros. Maybe the linear polynomial. How many zeros there will be for the linear polynomial? And the form. Everything I studied in 9th standard. X form is ax plus b. And degree is 1. So there will be number of zeros will be 1. Then quadratic polynomial x square plus bx plus c. And the degree is 2. Cubic polynomial. Degree is 3. Like that. So you have to find out how many zeros they have. Which figure they won't ask anything. Just you have to find out how many zeros from the figure. Clear? Okay. Now start. So number of zeros you have to remember. You have to find out the number of points of intersection on the x-axis. Okay. Here first figure. Just look. This is the first figure. Here x dash y dash, and the figure is like this. And how many times or how many points this figure intersect on the x-axis? How? Just look at the figure and just tell me. So this is the point, right? This is the x-axis, and here is the point. How many times intersect? Only one time. Suppose they are writing us here A. Here only intersect. That means 1 0. This figure got only 1 0. Clear? Next, just look to the next figure now. Here, x-axis is this one. How many times it intersect? This figure intersected 2 points. Here it is A. here it is A dash. How many times it intersects on the x-axis? It is 2 times. That means how many zeros are there? 2 zeros. They have 2 zeros. What are the next one then? Just look at the figure then. And this is the x-axis. Just look to the x-axis, it will be enough. And how many times it intersect? Now look. Here first time A, here it is A dash, here it is B. How many times it intersect? 3 times. So the answer is how many zeros there will be? 3 zeros. Suppose it does not touch on the x-axis. Here it is like this. Okay. What happens? What can you write there? How many zeros there will be? Here no points touches. Then what can you say? You can say that no zeros. Clear? If it does not touch means you can say that no zeros. Okay, just look to the question or just remember the figures first and then you have to find out. Here always the number of zeros they will ask you. Okay, one more question always they are asking for a CBSE. Here are the things you have to remember and examples also given in the textbook. Just look to the question, just look to the examples and find out your own. Hope all the problems you understood. Do it your own. And the homework is exercise number 2.1 full. No need to draw the figures in your notebook. Just check it from the textbook. Write the answers in your notebook. Clear? Okay. Thank you very much.